as possible without actually touching it. And I've made the mistake a couple of times, shredded a few belts by just having that too close to it, because you've got these basically sharp metal points right there that if they're too close, they'll hit the belt, shred it. All right, so we'll come back to this. This is an electroscope. No idea how well this is going to be. It's going to get picked up. Camera there, but you know, what the heck. You probably have the worst view of it. Can you see the two metal leaves in there?
No.
Can everyone see the two metal leaves? All right, so right now it is neutral. Now what I want to do is to charge something, so I'm going to take something like rabbit fur here. If you're concerned for the safety of the rabbits, have no fear. After they gave up their fur, they moved down to the Bahamas where they knew they would not need them. So they are all perfectly happy living on a farm. These are all the same. And so the way you transfer, as most of you have experienced in wintertime and shocking yourself, is you just rub one against the other. Now typically, those electrons are going one way or the other. Typically, plastics will take electrons and fur will give up electrons. So let's assume that's true. So that this is negatively charged. As I bring it closer to the leaves there, as I bring it closer, notice that the leaves move. Now they sort of go back to where they were. They move again, and they go back. So the first question I'm asking you is, based upon these two principles right here, why did the leaves move? This is negatively charged. What happened?
The leaves are positive. The leaves are positively charged?
No, this is neutral. You have just as many protons as electrons here. Ultimately, the leaves will end up being negatively charged. But right now, they're neutral.
Oh, wait, right.
So based upon that, how could the leaves become negatively charged?
As the plastic gets closer to it?
Why does that make the leaves negatively charged?
What are the leaves made of?
Aluminum, I believe. Some light foil. Aluminum's cheapest. So right now it's neutral. I've a bunch of protons and a bunch of electrons, equal number of both, net charge 0. What would put electrons there?
Well, if it's neutral, it wouldn't want to necessarily gain any electrons, would it?
That is true. But somehow it does.
Is the thing that connects them, the metal piece that connects the leaves?
It's this is metal right here. Just so you know, this is the conductor. This little black bit right here, I think it's bakelite. This is an insulator. The side here is metal, but from here down to So this is metal and it connects directly to this. Sorry. So we have a metal shaft here, not touching the metal casing. Probably something important like, we're calling about your car warranty. All right, where was I? All right, so you were asking about the connection. I'm just trying to get across that this metal shaft right here is connected directly to the leaves right here, but not touching the metal casing.
But could it have a different amount of electrons than?
Now you'll find
Even if
that
it's neutral, the leaves are neutral, but is the thing that connects the leaves neutral to the piece of metal?
it starts out neutral also. Right now, it's all neutral. And if it doesn't seem like it's neutral, we can always touch it to a larger source, such as that right there. And any excess electrons would go away into here, or if it is missing electrons, it would pull electrons from here. So what would cause electrons to go into the leaves then? If this is neutral to start with, and the leaves do repel,
If the plastic has too many electrons
yes,
and it wants to get rid of them,
yes.
then it would send them to where it's neutral?
No, not the way I did it. If it did, if the electrons did, I didn't touch this with the PVC pipe. I didn't touch it. So if it did, there would have been a spark. Now it's possible it was a very small spark and it was just too subtle to hear. But if it did spark and I suddenly put excess electrons on here, then when I pulled the PVC pipe away, the leaves would not have gone back to where they were. So we can assume that for what I've done so far, the electrons did not transfer.
Well, it's like when you take the battery and you try to put the same charge together and it doesn't touch. That's what I'm thinking of.
The battery.
Is it a battery? I don't know what it is. You try to,
With
or like
magnets?
a magnet,
Okay.
sorry, magnets. When you put the same charge to each other, they can't touch. Like they don't contact each other.
All right, just from a language, poles is a better word than charge.
Oh.
It's not really magnetic charge.
Oh.
So, but
Is that the same, like?
it is similar to that. I hesitate to say it's the same. They are very much related to each other, but the way magnetism works is a little bit different than the way electricity works.
Oh.
But that sort of goes along similar to this, opposite attract and like repels. All right, so let's go back to this is negatively charged. It wants to get rid of electrons, but it's not going to because I didn't let it. What happens when I take this negatively charged thing and put it near the knob here?
The electrons go closer to the point of where it would touch the conductor, like
Which electrons?
on the PVC pipe.
Insulators, so they're not going to move much.
No, oh,
They want to, but they're basically stuck. The electron
so
motel.
if the conductor is neutral, then the electrons would move farther away into the leaves.
Exactly.
and repel. Okay.
That's what's happening.
Exactly.
And then when I pull this away, the electrons come back. Now the electrons don't want to be there, but they're being faced with a much greater threat than what they have there. So as long as this is enough of a charge, it will chase the electrons down into the leaves, making them negatively charged, and now they are alike, they will repel. Now if I actually want to transfer, I have to get it closer or actually just touch it. So let's go ahead and do that. And sorry, Joanna. So I bring it closer, the leaves will spread, I will touch it. Notice that they jumped farther apart. So now I take it away, the leaves still stay spread. They came in just a little bit, but not a whole lot. The leaves are negatively charged. Now, if I need to neutralize it again, I just need to give it some source where all the excess electrons can go. Well, the Earth is a great source to dump electrons or take electrons, that's thus ground. But what's happening here, I don't have easy access to the Earth, so I can just use me. I'm significantly larger than this is. I just touch it and the leaves go back. I now have a few excess electrons, not enough to hurt me, so I'm not shocking myself. So let's bring up the Van de Graaff generator again. Less interested in the sparks, but notice what happens to this. And hopefully those metal bolts will not cause an issue. Anyone have a pacemaker? I guess, Naveen, you're closest. Pacemaker, do you have any? No. Okay. So let's turn this on. Notice those leaves are spread a great deal apart. This time, because the ball here is positively charged, it is pulling electrons up, making the leaves positive, and so they are still repelling each other. You can have some idea of the humidity in the room based upon how quickly those leaves will start to collapse again. And that is probably still charged here, so I don't really want to get too close to it. And back to where they were. Now, what's going to happen if I turn this thing on now?
The pan's gonna go up.
Unfortunately, it won't hover because I don't have that level of balance there. But why will the pan go up?
Because they're both metal.
Therefore?
The lights repel. The lights repel.
So why are they both like?
They have the same charge. Will they?
They will, but I guess all the pieces are there. Let's just put it into a sentence or two. Because this is a conductor, it's metal, it's a conductor. As this thing starts pulling electrons from the ball here, the ball is now going to be positively charged, so it's looking for a source of electrons, the pipan. So electrons will get pulled from the pipan into the ball and eventually into the belt and then sent away. So they'll both be positively charged. It should lift up. Yeah, ideally it would hover there, but it's not going to. And then the last one, and I need the glove for it. I'm going to turn this thing on. I'm going to take this styrofoam here. This is an insulator. Charges are not going to flow through it. So the question becomes, what happens when I put this near? What will happen to this piece of styrofoam? You said cry?
Fry.
Fry. Oh, fry. No, it won't fry. It hasn't yet.
Will it stick to it, the metal?
It will, but why will it be attracted to the metal?
Because they have different charges.
Well, they're both neutral right now. That will become positively charged, but this is an insulator, so how does it become charged?
You have static and insulate. Static,
What do you mean by that?
like in the styrofoam.
Oh, generally when you say static, it's building up of charges. It's not going to gain any additional charge. Not until it touches that. Well, first let's just show that happens, hopefully without hurting myself. It got sucked towards it and then shot off. So how does it get attracted? All right, for the sake of time, sorry, spoiler alert. The electrons are not moving. The electrons are pretty well bound to the atom itself. So I have, well, it's got carbon in it, it's styrofoam. So I have carbon with the 4 excess electrons here. These electrons are zipping around a carbon atom, but I've now exposed it to a positively charged source. The electrons will move to one side. They're not necessarily getting ripped out of the molecule, and granted that's not a molecule there, but they're not being ripped out of the molecule, but they are staying close to it. So now my carbon atom is polarized. So I have a bunch of electrons over here, making this side positive, that side negative. So even though this is attracted and that is repelled, the one that's attracted is closer. And so the net force on it is towards it, and so it gets pulled towards it. As soon as it touches, there's going to be some transfer, making the same charge, and so it gets pushed away. And that is, I guess, where we end our face-to-face experience for the semester. Please be safe over the holidays. And expect some online videos. I just haven't posted them yet for 110.
So will the test will be on 15 through 25, like the end of this?
Yeah, it depends on how far I feel like we've officially gotten.
Okay.
It's primarily concentrated on the wave bit, but
Okay. Thank you. Have a good Thanksgiving.
yep, you too.
Have a good holiday.
You as well.
Thank you.
Or holidays, plural.
Yeah.
Oh.